Hi everyone, welcome to our next bit of proofs. Okay, we're going to look at how we communicate proofs further today. Before we do that, I have a few definitions we need to go through that I need you to jot down. So you might want to pause the video and write them down once I've explained them. Okay, so your first definition is the word consecutive. Okay, and consecutive means in a row or one after another. So something like 1, 2, 3, 4 would be consecutive numbers. Okay, if I had consecutive even numbers, we might have 2, 4, 6, 8. Consecutive odd numbers, it might be 1, 3, 5, 7, and so on. So consecutive means in a row or one after the other. Even numbers are numbers that are multiples of 2. That's one way we can define them. How we would show this is to show that a number or an expression can be divisible by 2. Okay? And finally, odd numbers, you need to know that they are defined as one more or one less than an even number. Okay, so can you take a moment and pause this because what we're going to do next is use these definitions in order to show you some important generalizations. Okay, thanks for writing that into your notes. Now that you know what these three things mean, we should be able to look at some other things, okay, which include what are consecutive even numbers and what are consecutive odd numbers, but general forms, okay? So what I mean by general form is they could be any number. So if I want to look at just consecutive numbers to start with, okay, I could let my first number be n. All right, and if they're consecutive, each number should go up by 1. So my next number would be n plus 1, and my next number would be n plus 2, and so on. Okay, n plus 3, n plus 4, etc. Okay, so that's the first thing. If you're being asked in a question to work with consecutive numbers, they're not emphasizing whether they're even or odd, they're just saying consecutive numbers, you can use these as your numbers. Okay? Right. But they may ask you for consecutive even numbers. And if they ask you for consecutive even numbers, they have to be divisible by 2, and they also have to be 2 apart. Okay, so we know that 2, 4, 6, 8, those numbers are consecutive even numbers. So we have to mirror that in our generalizations. So the first one's going to have to be 2n because that's divisible by 2. Okay, if I want to carry on from there, I'm going to have to keep adding 2. So my next consecutive even number is 2n plus 2, and then 2n plus 4, and so on. You could technically go back and you would have 2n minus 2, 2n minus 4, 2n minus 6, and so on. Okay, so as long as they are 2 apart, I tend to start with 2n and move that way when I'm doing consecutive even numbers. Okay, a little bit easier than having negatives involved. Okay, and finally, they might ask you to work with consecutive odd numbers. And remember from our definition that odd numbers are 1 apart from an even number. So we have to show this in our generalization. So our first one could be 2n plus 1. Okay, that's 1 apart from an even number. We could then move to 2n plus 3 as the next one, and then 2n plus 5, and so on. Okay, similarly with our even numbers, we could take a hop back and we would have 2n minus 1. Again, I prefer to start here and go that way when I'm using my consecutive odd numbers. I avoid negatives. Okay, so can we take a moment, pause the video, and make sure you got that in your notes because we're going to need that for the questions that we look at next. Okay, well done. Okay, so we're now going to look at our questions from the textbook together. Okay, before we do that, let's just split screen that for you. A bit stubborn, come on. There we go. All right, okay, so we're going to start with these two questions, okay? So they're communication and reasoning questions. It says, prove that the sum of any odd number and any even number is always odd. Okay, so we have to make sure that this is generalized. Now, I have an odd number and an even number. They haven't said that they're related. They haven't said that they're consecutive. So I'm going to have a think about what I use to do this. Okay? When you have two different numbers in a proof, you have to use different letters. So I'm going to let the even number be 2n, because that's general. That could be anything. Okay? And I'm going to let the odd number, instead of using an n, I'm going to choose a different letter. We usually use an m. Okay? So I'm going to let that be 2m plus 1. Okay? And then I'm going to do their sum, because that's what the question has actually asked me to do. So we are going to add our 2n plus 2m plus 1. Now, how do I show that this is odd? Remember that the definition of an even number was that it was a multiple of 2. And the way we show that is to divide out a 2. Okay? And for an odd number, it has to be one apart, either one more or one less than an even number. So the way we show this is we show that this first bit here is divisible by 2. And the way we can do that is make it a multiple of 2 by factorizing out the 2. Okay? So once we do that, we can now make a statement. We can say, therefore, this is odd as it is one more than an even number. Brackets, multiple of 2. Okay, so we want to be really, really clear in a proof. We want a statement as well. Okay, as long as you've got a statement, you've explained what you've done, you've shown that proof, you're good. Right, then it says part B, explain why any odd number can be written as 2n plus 1 or 2n minus 1. So this is kind of an extension of this. Okay, so we could say that 2n is even. And then we could say that since an odd number is one more or one less than an even number, two n minus 1 and 2n plus 1 must be odd. Okay, so that's really key, those three definitions we went through at the beginning, because they come up all the time in your reasoning questions and exams, and you need to make sure that you're confident to relay that information and to explain what odd and even numbers are. Okay, and then use those definitions in those explanations. Okay, so we're going to move on to these. Now, I'd like you to, I'm going to make it full screen. I want you to just have a play with them, see what you do, okay? And then obviously we will go through them together. Okay, so let's just make the full screen for you. Press pause, have a go. These are try questions. We will then go through them together, okay? Okay, guys, thanks for having a go. Let's take a look. Right, so we've got here the nth even number is 2n, which we know. Explain why the next even number is 2n plus 2. Okay, so 10a. So we know that 2n is even. And we should know that even numbers are divisible by 2. Okay, so even numbers are divisible by 2. Now there's different ways you could explain this, okay? The simplest way is to say that therefore even numbers will always be a value of 2 apart. of 2 apart when consecutive. Okay, you have to get that word consecutive in because that means in a row or in an order. Okay, if you just say 2 apart, well, that doesn't make sense because 44 is not 2 apart from 88, and they're both even numbers. Okay, but when we're looking at them in a consecutive version or a consecutive form, then they have to be 2 apart. Okay, we could consider the first term to be n and the second term to be n plus 1. Okay, and if we did that, we could divide out the 2 and show it that way. So 2n is the same as 2 times n. 2n plus 2 is the same as 2 times n plus 1. If n represents the first term, n plus 1 is the second term. Okay, and this would show that these even numbers are consecutive. Okay, so we could have used that in our explanation as well, although this would suffice in an examination. Okay, all right, so well done. Part B says, prove that the product of 2 consecutive even numbers is a multiple of 4. Okay, now product we have to know means multiply, so the first thing I'd be thinking is, what is product? Okay, and we make sure we remind ourselves that that's to multiply. Okay, and it says that they have to be consecutive even numbers. So now I know because of that consecutive, we're going to use the same letter. Okay, so we can let the even numbers, or let the consecutive even numbers, be 2n and 2n plus 2. Okay, just like we learned. Okay, and now we're going to find the product. So when you're laying this out, I always like to write exactly what I'm doing. So I would say I'm working on the product now, like this, okay? And that's going to be 2n times 2n plus 2. I'm going to need to expand, so I want to make sure that I use a bracket there. And that is equal to 4n squared plus 4n. Now they said to show that it's a multiple of 4, okay? So the way I do that is I divide out the 4 by factorizing. Okay, and then we can say, since this is divisible by 4, it is a multiple of 4. Okay, lovely. Right, let's look at question 11 together. It says, prove that the product of any 2 odd numbers is odd. Okay, now careful. It doesn't say consecutive, so we're going to have to use different letters, okay, because it's not consecutive, and any 2 odd numbers, okay? So as long as we use different letters, we can let the 2 odd numbers be, so we can use 2n plus 1 and 2m plus 1. Okay, so use an n, use an m, they're both odd, very good. And then it says prove that the product of them is always odd. Okay, so now we're going to have to multiply them together. So we say we're finding our product. Okay, so that's going to be 2n plus 1 times 2m plus 1. All right, we need to expand those double brackets, so 2n times 2m is going to be equal to 4mn. Okay, plus 2n plus 2m, and then 1 times 1 is 1. Okay, now remember the definition of our odd number is it's 1 more or 1 less than an even number. How do we show that? We're going to divide this whole bit by 2, but leave the 1 separate. So that's going to be 2 times 2mn plus n plus m when I factorize plus 1. Okay, now if you want, you can annotate in an exam. So you could say that this is a multiple of 2. And that way, when you do your explanation, you've already explained that through showing your work. Okay, so now we can say that since this is 1 more than a multiple of 2, brackets even number, it must be odd. Okay, all right, so once again, since this is 1 more than a multiple of 2 or an even number, it must be odd. Right, so that brings us to question 12. Let's take a look at that. Okay, this one says, given that 2 times the x minus a is equal to x plus 5, where a is an integer, show that x must be an odd number. So I mean, really what we need to do is isolate x. Okay, so that's code for let's get x as the subject so that we can actually talk about it. Okay, so that's going to be 2 brackets x minus a is equal to x plus 5. Okay, that we can expand into 2x minus 2a is equal to x plus 5. If we're going to get x by itself, we need them together, so let's take away the x from both sides. Okay, that's going to give me x minus 2a is equal to 5. Okay, and then we have to add the 2a so we can get x by itself, which gives us x is equal to 2a plus 5. Right, now remember they're asking us to show that x is an odd number. Now this 5, I know that that's an odd number plus an even number. That's one way we could state it. It doesn't quite go with the definitions, so we'd rather state it to go with the definitions. I can split up the 5. So we're going to write this as x is equal to 2a plus 4 plus 1. Now I've got that 1 separate, I'm going to be able to give my definition of an odd number. Okay, so finally we divide out this 2. Make sure that you annotate. So we say that that's an even number. Okay. And then we give our explanation. So since x is 1 more than an even number, x must be odd. Okay, right, so well done on those. That's really impressive. Okay, so I'm going to make this bit full screen for you, just so you can pause and have a go. Okay, once you're done, we will go through the answers together. Okay, well done. Let's take a look. Okay, right, so for question 14, okay, so let's write it out first so that we know what we're doing. They're asking us to turn this into something over x times x minus 1 times x plus 3. So we've got 1 over x squared minus x, take away 1 over x squared plus 3x. My suggestion is we factorize those denominators, so that's going to be equal to 1 over x times x minus 1 minus 1 over x times x plus 3. I'm hoping you can now see where that denominator they talked about came from. Okay, from our algebraic fraction work, we're going to want to multiply this one by x plus 3 and this one by x minus 1 so that we can make the denominator the same. Okay, so x plus 3 okay. And when we bring that together, you need to be extra careful to keep this bit in a bracket until you distribute that negative. So on the top, okay, we have 1 times x plus 3, which is x plus 3. I'm going to keep it in a bracket for now. We are taking away 1 times the x minus 1. I'm going to keep it in a bracket because remember, we're going to take away both of those bits, okay? All right, and on the bottom, we have our x and our x minus 1 and x plus 3, just like in the question. Okay, so let's take a look. That's x plus 3. We're taking away the x, and then we are taking away a negative 1, so don't forget that that's a plus 1. Okay, all over our x minus 1, and x plus 3. And that will give us x, take away x is nothing, okay, and 3 plus 1 is 4. So we have 4 over x times x minus 1 times x plus 3. Okay? Right, and they've asked us to show that. Well, we've shown that, and they also asked us to state the value of a, so we can now say that a is equal to 4. So well done, those of you who got that. Okay, so if you didn't, don't worry. You need to go and review your algebraic fractions in some of the previous videos to make sure that you've solidified that. Okay, right, question 15 states, prove that n squared plus n is a multiple of 2 for all values of n. Prove that n squared plus n is a multiple of 2 for all values of n. Okay, so what are we going to have to do? Well, we're going to have to think about what an odd and even number is, okay, and also what their products are. Right, not a problem. Let's first factorize that because I can do that, okay? So we're going to have n and then n plus 1 when I factorize that. Now, what is our definition of an even and an odd number? They're one apart from each other, yes? So since n and n plus 1 are one apart from each other, one of the numbers must be even and one of the numbers must be odd. Okay, now that's important because we can now state that the product, this is a product here, n times the n plus 1, of an even and an odd number is always even, and therefore n squared plus n must be even. Okay? So we can now add that since the product of an even and odd number is even, n times n plus 1 must be even. And so n squared plus n will always be even. Now, you may think that's a lot of writing, okay, but remember that this is a communication question. It's a proof, okay? If this is a 3-mark question, most of your marks is coming from your explanation, so you need to make sure it's very clear. It doesn't matter if it's a bit repetitive. I'd rather it be clear, okay? And then that way we guarantee that you get the mark you deserve for that, okay? So well done. Hopefully we've understood that. If you have a question like this again, please factorize it, see where it takes you and where it leads you, and then hopefully you can link that to even and odd numbers and create that explanation. Okay? Right, question 16. Okay, so this one says, for part A, to write an expression for the product of 3 consecutive integers. Now, they've given them to you, okay? n minus 1, n, and n plus 1. So let's do that. So we've got n minus 1 times n plus 1, okay? Let's do this bit first. That's going to be n squared minus n, all times n plus 1, okay? N squared times n is n cubed. N squared times 1 is plus n squared, minus n squared, and then minus n, which is going to give me n cubed. Those go away, minus n. Right, so we've done that. Part A sorted. Part B says, hence show that n cubed minus n is a multiple of 2. So once again, we need to show something about even and odd numbers. Well, even times anything is going to force a number to be even, okay? So what we can now say is that since n cubed minus n is equal to n minus 1 times n plus 1, it is equal to the product of 3 consecutive numbers. Okay, we can then state that at least one of these numbers must be even as a result. Okay, then we can state that the product of an even number times any number will be even. So since the product of an even number and any other number is even, the expression n cubed minus n must also be even. Okay, so proofs are all about reasoning. Okay, reasoning and making sure you know those definitions and how to apply them. All right, so well done. Take a moment and pause it, go back through it. I'm happy for you to do that, obviously. Okay, before we move on to the exam question, if you need to go back, go look through, because I'd like you to try this exam question and really test your understanding of this lesson. Okay, so let's make that full screen. There we go. Right, pause it, try it, and then we'll see how you did. Okay, all right, hopefully that went well. Let's take a look. Okay, right, so this one says, prove algebraically that the difference between the squares of any two consecutive integers is equal to the sum of these two integers. So there's two separate things we have to work with here. A difference between the squares of any two consecutive integers and also the sum of those two integers. Okay, and the word consecutive is there, so I can use the same letter, so that's useful. It hasn't said whether they're even or odd, which is good. So actually, we now need to decide what we're going to use as our consecutive integers. So let's let our consecutive integers be n and n plus 1. Okay, remember we don't have to worry about even or odd, and therefore we don't need a 2 there. Okay, then we want to work out the squares because we're going to need that. Okay, so for our first one, that's going to be n squared. And for our second one, it's going to be n plus 1 squared, which we can write as n plus 1 times n plus 1, which is n squared plus 2n plus 1. Okay, so we've got both of our squares. It then says to find the difference. So let's do that. So difference of squares. Okay, the reason I've labeled these is quite useful is now I can say that I am doing the second one minus the first one. Okay, which we know is going to be n squared plus 2n plus 1 minus n squared. Those go away, leaving us with 2n plus 1. Okay, now the second bit of the question said that we wanted to show that this here that we just found is equal to the sum of those two integers. Okay, so that's the last thing we're finding is the sum of the integers. Okay, which is n plus 1 or 2n plus 1. Then we just need to say that therefore the difference of the squares and sum of the integers are both equal to 2n plus 1. Okay, and we've shown it. All right, so that's lovely. Hopefully you had a statement at the end. Hopefully you were able to work through this, okay? I'm very proud of you today. That finishes the extended algebra unit, okay? So well done. Next videos are going to be related to strengthening your understanding and extending your understanding before you complete the test online, okay? So very proud of you and well done. Good work.